So hello guys, welcome back to my channel Future Studies. Now I'm gonna start this chapter waves. Now let's learn about the type of waves. Let's learn what are the waves. The wave is the disturbance that propagated in space that transports energy and momentum from one point to another point without the transport of matter. Without any transport of matter. There are two types of waves. The waves are divided into two types. Again, they will be divided in some more types, but first we will learn this. The first one is mechanical waves, and the second one is non-mechanical waves. What are mechanical waves? Mechanical means waves. The mechanical waves, they require some medium for the propagation. They do require some medium. Uh, for example, let's see the waves on a string, waves on a spring, waves on water surface, and sound waves. You know it very well. And then if we come to a note that a medium must possess elasticity and inertia to transport disturbance through it. What is disturbance? Disturbance means here the wave is the disturbance propagated, and it would be formed like this or through rarefaction and compression. I would be say in this class only, but after this one. And then if we go into the next point, intermolecular forces are responsible for transversions of wave through medium. Intermolecular forces are responsible. If that is a solid, then the intermolecular forces will be strong, and if it's liquid, it would be somewhat weak. And if it's gases, then there will be so much distance, and it would be very weak. So, as the as the wave depends on the matter properties, it depends on the intermolecular forces also. If we come on to the second type of the waves, non-mechanical waves, they do not require any medium for their propagation. Why they don't? As you see the light and some electromagnetic waves, all types of electromagnetic waves, if we pass through vacuum, they also travel in them. Why? Because they are non-mechanical waves. They do not require any medium for the propagation. So if we come to the next thing, waves are divided into other two types. The previous one is two types and is based on other kind of thing, right? On considering on the vibration of particles, transverse mechanical wave and longitudinal mechanical wave. First, let's learn about the transverse mechanical wave. Particles of medium vibrate in direction perpendicular direction of propagation of wave. If you see it, wait a second, yeah. If you see it, particles of the medium vibrate in direction particles. See, this is the what propagation of wave. It's what assigned with this arrow, and the wave is traveling upward and downward, means perpendicular direction to the propagation of wave. It travels in the form of crests and troughs. The highest point here is the crest and highest point here is the trough. So upward we denote as crest and downward we denote as trough. As we come to the next type of the wave, considering the vibration of particle, then longitudinal waves will be the next, right? Longitudinal waves. Particles of medium vibrate parallel to the direction of wave motion. See those this wave is traveled directly parallel, and as the above one is traveled perpendicular, but this is parallel. Particles of medium vibrate parallel to it, and then the next point is it travels in the form of compression and rarefaction. This is the most important point. As you can see there, some gaps are some gaps and some, what how can I say, one thick region and one not so thick region. You can see it. The thick region is represented by C and other is R. C is mean by compression. As we compress it, how it would be, it's right. So it would be like that. And the rate fraction is the molecules will be apart with some distance. As we move from the next to the next waves are again divided into other two types. So this time they are considering the basis of energy propagation. On the basis of energy propagation, for example, number one is the progressive wave, and the number two is the stationary wave, right? Progressive wave. These waves advance in a medium with definite velocity. These waves propagate energy through the medium. They carry the energy and moves in a medium from it moves from a medium, like example, light waves and sound waves, etc. These waves advance in a medium with some the specific velocity, definite velocity v, right? If we come to the next one, the stationary waves, these waves remain stationary through two boundaries in two medium. Like if there are two boundaries, let me show you. If there are two boundaries, this wave propagate only in this. Right, see, let me show it. If we touch with tuning fork, then it would be moved like this. So these type of the waves on a string attached to two closed end or one open end, from right, that's organ pipe, right? So like that, in this case these waves remain stationary through two boundaries in medium. See, there are two boundaries and then the waves remain stationary through it. The energy is not propagated. As the previous case, the energy is propagated, carried through progressive wave, but in the stationary wave there is no propagation of energy, but it is confined into segments. See this after touching with tuning fork or after plucking with hands, we can see that some of the segments, confined segments or loops are after reflecting, it would come here like this, like this, and it would become a loop. So this is today's video, and like, share and subscribe my video.